Today, we're setting off on a journey beyond the Milky Way to explore the most remote and mysterious corners of the universe. Are you ready to encounter galaxies so strange and wonderful that they seem straight out of a sci-fi movie? Get ready to have your mind blown. Strap on your astronaut helmet, buckle up your intergalactic seatbelt, and let's take off. The Andromeda Galaxy, also known as M31, stands out as one of the most fascinating neighbors of the Milky Way in the vast universe. This spiral galaxy, located approximately 2.5 million light-years away, is the closest to us and has a shape similar to our own galaxy. With about 1 trillion stars, its magnitude and complexity are truly impressive. Andromeda's bright core, visible even with the naked eye on clear nights under ideal conditions, houses what is believed to be a supermassive black hole, whose mass and gravitational influence are subjects of intense study. One of the most intriguing curiosities about Andromeda is its cosmic fate intertwined with that of the Milky Way. Astronomers predict that in about 4 billion years, Andromeda will collide with the Milky Way in a spectacular galactic merger event. This encounter will not only radically transform the structures of both galaxies, but will also result in a new galactic formation, sometimes referred to as the Milkomeda or Lactomedusa galaxy. During this process, it is unlikely that individual stars will collide due to the vast distances between them, but gravitational interactions will reconfigure the orbits of stars and alter the properties of the galaxies. Besides its fascinating future, Andromeda also serves as a celestial lab for studying star formation and evolution. The galaxy contains several active star-forming regions, visible as areas of intense brightness when observed in different wavelengths, especially in ultraviolet. These regions are crucial for understanding how new stars are born from clouds of gas and dust, a process that still poses many unanswered questions for current science. There's still much we don't know about the Andromeda Galaxy, especially regarding the exact implications of its future merger with the Milky Way. Ongoing research and simulations continue to provide insights into how galactic interactions might influence the evolution of galaxies and the fate of stellar systems within them. The Black Eye Galaxy, formerly known as M64 and nicknamed the Sleeping Beauty Galaxy, is one of the most striking galaxies observed by astronomers. Situated approximately 17 million light-years away in the constellation of Coma Berenices, this spiral galaxy is easily recognizable by a dark band crossing its bright core, reminiscent of an eye with a bruise. This visual aspect not only names the galaxy, but also adds an element of mystery to its history and formation. The contrast between the dark band and the intense brightness of the core is what most captivates attention in M64. This contrast is thought to be the result of previous galactic interactions or mergers, which have influenced both its current structure and internal dynamics. These past events are critical for understanding not just the appearance of the Black Eye Galaxy, but also its evolutionary properties. Despite its beauty and intriguing features, much remains unknown about the Black Eye Galaxy, especially in relation to the impact of these structures on its ability to form new stars. Astronomers continue to study how internal processes, including the movements of gas and energy, contribute to the stellar life cycle within M64. How the galaxy regulates star formation may offer valuable insights into broader galactic processes. Also known as M81, is one of the most spectacular sights in the universe accessible to observers from Earth. Located in the constellation of Ursa Major, it stands out as one of the brightest galaxies in the night sky, making it a favorite target for both amateur and professional astronomers. This spiral galaxy is characterized by a prominent central structure and well-defined spiral arms, which are highlighted by the presence of star-forming regions and emission nebulas, creating a visual spectacle of light and color. M81 is particularly notable due to its interaction with the nearby Cigar Galaxy, M82. This proximity is not just a spatial coincidence. It has profound implications for the structure and evolution of both galaxies. It is believed that about 300 million years ago, M81 and M82 underwent a close encounter that resulted in significant material exchange and a subsequent burst of star formation. This encounter left M81 with more prominent spiral arms and a more defined structure, while M82, an irregular type galaxy, was dramatically affected, with intense star-forming activity triggered by the interaction. There's still much we don't know about the past and present interactions of M81 with its neighboring galaxies. While the historic encounter with M82 is well documented and studied, the exact details of how these interactions influence the morphology of M81 and its subsequent development remain partly mysterious. Astronomers use a variety of techniques, including computer simulations and multi-wavelength observations, to try to reconstruct the dynamic history of the galaxy and predict its future evolutionary path. The Sombrero Galaxy, scientifically known as M104, is one of the most iconic and photographed galaxies in the study of astronomy, due to its distinct appearance resembling a Mexican sombrero hat. This galaxy is located about 29 million light-years away in the constellation of Virgo, and is particularly notable for its extremely bright central bulge and a prominent dust ring that encircles the core. Beyond its remarkable appearance, the Sombrero Galaxy is one of the most massive galaxies in the vicinity of the Milky Way. Its mass is estimated at about 800 billion times the mass of the Sun, making it a significant object of study to understand the formation and evolution of similar galaxies. The central bulge of M104 is particularly dense and bright, suggesting a high concentration of old stars. This feature also indicates the possible presence of a supermassive black hole at its core, which is typical in galaxies with such luminous and dense cores. However, there is still much to learn about the extremely dense core of the Sombrero Galaxy and the dynamics of its unusual structure. The dust disk that characterizes M104 is not just an aesthetic detail. It plays a crucial role in the internal dynamics of the galaxy, influencing star formation and mass distribution. Researchers are particularly interested in understanding how this dust ring interacts with the central bulge and the galaxy's halo, as well as what processes are behind its stability and maintenance over time. And so, we conclude our epic journey through the universe's most obscure and impressive galaxies. I hope you've been as amazed as I am by these cosmic giants that, despite the distance, make us feel a bit more connected to this vast universe. If you enjoyed exploring these intergalactic wonders, don't forget to leave a like, subscribe to the channel, and turn on the notification bell so you don't miss our next space adventures. Until next time, space explorers, where we'll continue to unravel the mysteries of the cosmos together.